All right, so we are on Unit 4, Lesson 3, and this is called Finding the Zeros of Polynomial Functions, and these are going to be cubic functions today. Cubic means my degree or my highest exponent on an x is going to be what? 3, right? Next one. So these are going to be functions with a degree of 3. So pretty much, we know that when we're trying to find zeros, we are finding solutions to the polynomial. One method to do that is by graphing and seeing where that graph crosses the x-axis, right? So we know we can find real zeros of any polynomial by graphing. But we also know that there's limitations of graphing, which are that we can't get exact rational and irrational zeros, mainly irrational zeros, and it doesn't give imaginary solutions. So if there's imaginary solutions, then I'm not going to be able to look at the graph and see where it crosses the x-axis for the solution. So today's lesson is going to be on an alternate way to find the zeros, and it kind of builds on what we did last time. So in lesson 2, we saw that if we know 1, 0, we can reduce. If we know 1, 0, we can reduce the cubic polynomial to a quadratic. Quadratic means it's going to be an x squared, right? And then we solve the resultant quadratic by factoring or the square root method or the quadratic formula. But we were given a 0 last lesson, right? The only difference this time is that we are not given a 0, and so we're going to need to solve a cubic polynomial when we're not given a 0. All we're going to do is just graph the polynomial, find 1, 0, and then divide by that 0. All right? So here's your basic outline for your steps. And we can make it even easier here. Step number 1 says graph and find a rational 0. Integer 0 is better. So our first step is just going to be graph and find 0. Right? We want to graph and find a 0 where it crosses the x-axis, and preferentially where it's at an integer, like -2 or 0 or 5, just a nice number that's easy to work with like that. After that, we're going to use synthetic division. We're going to divide by that 0, and that should reduce it to a quadratic, and then after that, we're going to either solve that quadratic by factoring or the quadratic formula, pretty much for us. All right? I think this will all make sense, a little bit more sense when we look at an example problem. It's going to look a lot like what we did last time. So example problem number 1 says find all the zeros of this polynomial. And it's a cubic polynomial. So I can tell right away how many total zeros there's going to be. How many total solutions or zeros are there going to be? There's going to be 3 because it has a degree of 3. Remember, that includes their multiplicity. Sometimes we have double zeros, and those would count as 2. Right? We'll see some examples like that. All right, so here's the deal. They give us this cubic polynomial. Our first step is going to be to graph and find a 0. Can you guys throw this in your graphing calculator? And find a 0 that's an integer for me. An integer means like one of the numbers on the number line, like the counting numbers. -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Another way to think about it is a whole number. So you can throw that into your y equals and find a 0 in your calculator. Graph this and find a 0. That's an integer. Second calc, 0. So it's going to ask you to be left bound of where it crosses the x-axis, and then right bound, and you just find those places and then hit enter.
So on all of them? Well, mine was not like that.
Yeah, this is a different one. I have to clear this out.
So wait, do I do it on all three?
Yeah, you want to do it on all of them until you find at least one that has an integer value. Did you get it yet, Devona?
No.
No? Okay, so let's throw this in there and see what we get.
Wait, is it y or x equals 0? I don't know what I write down.
All right, so check it out. We got x to the third plus 6x squared plus 2x minus 9. All right, graph that. So I can see there's three solutions, right? Right here, 3 zeros. So if I go to try to find their exact value, I'm going to go to second calc 0.
And x equals
1. Okay, you found one? Good. You found one at x equals 1, right? So let's just say I was going to try to find this 0. If I hit enter, and then right bound, I'm enter again, it's going to give me x equals negative 1.697224. That doesn't work for me because it's not an integer. It's not a whole number. It's the easiest way to think about it, right? So I need something that's actually a whole number. So that one didn't work for me. Let me try this other one over here. That looks like it might be a whole number because it's crossing right on one of the tick marks. So I'm going to go second calc 0 again. Move over here. Left bound. Right bound. Boom. X equals 1. Cool. So I found one of my solutions. And to find my other solutions, these are what you call irrational solutions. So I can't just take the calculator and calculate them using that same method and get an exact number for them. So what I need to do is now I need to take the one solution that I did know, that 1, 0, and I'm going to divide by that using synthetic division. So I'm going to use that and divide by that in synthetic division. So I'm going to set that up as my 1 over here. Draw my lines. And I'm going to copy down the coefficients of my polynomial up here, but I need to make sure that if there's any gaps in my exponents, I need to fill them in with a placeholder, right? In this case, I don't have any gaps because I have an x to the third, an x squared, an x, and then a constant. So I'm good to go there. So my coefficients are 1, 6, 2, negative 9. Right? Remember, your first step is just to take your first term and bring it down. So bring that down, I have a 1. And now I do 1 times 1 is 1. And I add here. 6 times 1 is, or 6 plus 1 is 7. 1 times 7 is 7. 2 plus 7 is 9. 1 times 9 is 9. And negative 9 plus 9 is 0. Boom. I love seeing that 0 because it means I don't have any remainder at the end, right? That's exactly what I want to see. So I now have my coefficients down here, and I'm just going to fill them in with x's. And since I started off with my original equation as x to the third for my first term down here is going to be x squared. I'm going to decrease my exponent by 1. So I have 1x squared plus 7x plus 9. And it works out perfectly. No remainder. Boom. With me? It's kind of like last lesson, right? So, all right, so I could rewrite this actually as just x squared. Same thing as 1x squared. Cool. So what that means is if I took this polynomial and multiplied it by the factor form of this polynomial, which would be x minus 1, if I multiplied these two things together, I would end up with my original polynomial up here. All right? But what I'm looking for is I'm looking for all the zeros of it. I already know one of them as x equals 1. And now that I have this part as a quadratic, then I can solve this with using a couple methods. I could try to factor it, or I could solve it using that quadratic formula. All right. So my first thing is to see if I can try to factor this, and just from looking at this, I can tell that this one's not factorable. Okay, so I'm going to have to use the quadratic formula to solve this one. You guys remember how to do that? It's been a little while. Formula is written up here. You'll have it on your note sheet on the SOL. But the formula is, actually let me underline this. All right. Use quadratic formula. My quadratic formula says x equals negative b plus or minus square root of b squared minus 4ac. And all of that divided by 2a. So this is where we had to identify what's our a, b, and c. And looking over here at my quadratic, my a is whatever is the coefficient on the x term, x squared term. So my a in this case is going to be a positive 1. Let me write it over here. A equals positive 1. That would be right here. My b is going to be a positive 7 because that's out in front of the x. And my c is going to be 9 because that's my constant. See how I got those, guys? Cool. So now I'm going to do is throw those values into the quadratic formula and calculate. But before I do, does anybody have any questions up to this point? So my formula now becomes x equals negative b would be negative 7, right? Plus or minus square root of b squared, that would be a 7 squared, minus 4 times a, which is 1, times c, which is 9. All of that over 2 times a, which is just going to be 2 times 1. Just substituted in a, b, and c for that. With me? Now I just need to simplify. Come down, I'm going to have x equals negative 7 plus or minus square root of, this will be 49 minus 36 over 2. I can simplify further. Negative 7 plus or minus square root of 13 over 2. My bad, this line has to come all the way over still. And now I look to see if I can simplify this radical in any way. For those of you guys that came into the class late, we talked about how to simplify these radicals. In this case, there's no way to simplify that radical because there are no factors of 13 that are perfect squares. All right. I can also look to see if my coefficients here and here and here share a common factor and simplify there, but they don't. So there's no, I can't simplify that any further. Okay. So what that means is that these are going to be my other zeros right there. I have 2 answers right there.
Wait, so is that our final answer?
So I'm going to show you right now how to write out your final answer. So first of all, don't forget about your initial zero that we found from graphing, right? So my first zero is going to be a 1. How about we write zeros? X equals 1. That was my first one, right? My second one is going to be negative 7 plus square root of 13, all of that divided by 2, right? And my third one is going to be negative 7 minus square root of 13, all of that divided by 2. So those are my zeros. That answers our question of finding all the zeros. And if we think about it, it makes sense. We have 1, 2, 3 zeros, and since we had a degree of 3, we knew we were supposed to have 3 total zeros.
So it's kind of like what we did a while ago.
It's kind of combining like a lot of stuff we've been doing
Okay.
all together, right? The quadratic formula to solve once we get it down to a quadratic. Yeah, I guess just to totally recap, here's what we did. They gave us our polynomial, and they said find all the zeros. So the first thing we did was we graphed it. We saw it came up, down, and came back up. So it had 3 zeros on here, right? But only one of them was at an integer. It was this one. It said x equals 1. Okay? So we use that as our starting point. And we came over and we divided by that. When we divided by that, it changed it from a cubic to a quadratic polynomial down here. And once it was quadratic, we could use that quadratic formula to solve for the other 2 zeros.